Okay, 9-5 is geometric series. So just like arithmetic series, it's the sum of all the terms in the sequence, except it's geometric sequence from adding all the sums in the geometric sequence. I should say geometric. Here's the formula. All you really need are the first term, which is A1. The R is the common ratio, and the N is the number of terms in the sequence or series. So for this first one, I'm going to write the formula up here. In order to find my A1, my R, and my N, my A1 is going to be 3. That's the first term. My R, the common ratio, I'm multiplying by 2 every time. So my common ratio is 2. And then my N I'm going to have to find. I'm going to use the AN formula, but because this is geometric, I'm going to use the geometric formula for the AN. And I know I'm looking for what term number 3072 is. So that 3072 goes in the AN spot. My A1 is 3. My common ratio is 2. And now I can solve for N. This is a exponential function, so I'm going to solve it using exponential function. First divide by 3, and I get 1024, 2 raised to the n minus 1. Okay, now it's in exponential form. You can solve it two ways. You can put it in log form. It's log base 2 of 1024 is equal to n minus 1. Log base 2 of 1024 becomes 10. And then solve for n, add 1, n is equal to 11. You could also get this 1024 as a power with base 2. It would be 2 to the 10th. You have 2 to the n minus 1. Now the exponents would be equal to each other, and you still end up with the same thing from there. So now I'm able to use this SN formula. And I'm finding the sum of the 11 terms. My first term is 3. My common ratio is 2. And my N is 11. From here, I'm going to erase this. From here, it's making sure you do your order of operations first. You have to do parentheses, but inside that parentheses, I had an exponent, so I have to do that first, which is going to be 2048. 2 raised to the 11th is 2048. I'm going to come down here, 3 times 2000. It's actually going to be negative 2047 over negative 1. That becomes negative 6141 over negative 1, which is 6,141. So the sum of that first 11 terms in that sequence, 6,141. Okay, so now to do the second one. I know that this is geometric sequence because it's written as an exponential form. Okay, the variable is in the exponent, which means it's going to be a geometric sequence. If it's arithmetic sequence, remember it's going to be in slope-intercept form. So I can use that same sum formula, A1, 1 minus r raised to the n over 1 minus r. The n in this case is going to be 20. The A1 I'm going to get from the formula. Okay, well, your AN formula for geometric is here. So this A1 is actually going to be 4, but you can always plug in a 1 in for n, and 1 minus 1 is 0, 1 half raised to 0 is 1, times 4 is 4. Okay, and my common ratio is what's being raised to that variable of the exponent, which is 1 half. So I have 4 times 1 minus, this is going to be 1 half raised to the n, which in this case is 20, over 1 minus 1 half. 4 times 1 minus, this number becomes really, really, really small. Okay, so what that really is going to be when I do 1 minus a really, really, really small number, it's going to be approximately 1. You're really not subtracting much. So it's going to be 4 times 1, and this is actually an approximation. Divided by 1 half, 4 divided by 1 half, or divided by 0.5. Dividing by 1 half is the same thing as multiplying by 2. It's reciprocal, so that's going to be approximately 8. Here's the U-try problems. Pause it and try these. Be careful. You got to be very precise with these. I'll go over them in a few seconds, but try them on your own first, and then you can check my answers. Okay, I'm going to give you the answers here, so pause it. Okay, here are the answers. For 3, it was 315. For 4, negative 1705. Now, the big thing with this, notice how when I'm plugging in, I'm going to use the purple pen. When I'm plugging in the R, you use the negative, and then you have to raise that to the exponent first, then apply this minus sign. It doesn't become, the negative and negative doesn't become a plus right there. Okay, it does in the bottom, but not in the top, because you have to raise it to the exponent. And when it's raised to an even, that number actually becomes positive, and then you're subtracting the positive number, not the negative number. Okay, and that happened on both of these, so be careful with that. You can see all the work there. After I found the n, I went back up here and then did the SN from there.